Hi guys, welcome to another weather lesson. I am meteorologist Alexandra Cranford and we are talking today about another weather topic, and I'm so glad you guys are with me today. It is Tuesday toward the end of May and we're all kind of still thinking about how to spend our time. Maybe you're able to get out a little bit more, or maybe you have kids or no students who are who are kind of thinking about maybe getting back into some school lessons after taking a bit of a break. I don't know, summer's coming up. I don't know what kids are thinking or what parents or teachers are thinking at this point. But if you're in the mood for some science material, what we're talking about today is air pressure. So this one is one that is a very basic sort of weather topic and atmospheric science topic, and yet we haven't covered it yet somehow. So I wanted to talk about that today. And you guys, thank you so much for all of your comments. Oh wow, it's showing me where you guys are watching from. How fun to see where you guys are tuning in from. We are in New Orleans, of course, and I'm coming to you still from my home doing these weather lessons from home in New Orleans. And I have my little cat Ben just out of the camera frame over here, by the way. He's napping. I don't know if my voice is gonna wake him up or not this time. But okay, so what we're talking about today is air pressure. And I was talking with someone recently who kind of reminded me that there are some things that are very sort of intuitive and that we can very easily recognize with the weather. Is it hot or is it cold? Temperature, very tangible sort of idea that we can think about. We can feel it when it's hot. We can feel it when it's cold. It's very easy to understand what the different temperatures mean and other things like that. Humidity, another one. Most of us can feel the humidity, whether it's there or not, especially in New Orleans. But air pressure is something that we can't really necessarily see or feel all the time, but it is so important in our weather topics. And if you watch our weathercasts, we're talking constantly about air pressure. So this is one of the chances that I get to go into detail a little bit with it and talk about it a little bit in more detail. So air pressure is a simple concept. It's that the air, the atmosphere, is made up of these little atoms and molecules, and they're all moving around in random directions. And when they hit something, a surface, they exert a force. And so that would be the air pressure. It's really as simple as that. And so when we talk about air pressure, there are a couple of different ways that it changes. Number one, with weather, is when a system is moving in, a migrating weather system crossing the US, coming in from the Gulf, settling over the Southeast, different kind of air masses with these different properties. And sometimes, of course, they're denoted by either high or low pressure, which we will talk about in just a second. That's when it gets kind of cool and interesting as far as weather goes. But just kind of at the very basic of pressure, there are kind of two ways that you can increase pressure. One is to add more air, like you would to a tire, and another would be to heat it up, because that adds energy to the little molecules. They strike whatever the container is with greater force, and so that is an increase in pressure as well. So just to get into a little bit of the science of that. Also, one thing to think about with pressure is that it is different as far as the air pressure goes depending on where you are. So if you are at or below sea level, like New Orleans, you have a different pressure from what's happening at a higher elevation. For example, on a mountain, where you would be higher up in the atmosphere, where there are fewer air molecules and where the air pressure is therefore lower. So do you guys remember when we were talking about the different layers of the atmosphere? Air pressure down here much higher than up here because there's so many more air molecules. And in fact, this is something you would learn in a meteorology course, but one thing that really interested me when I started some of this was that half of the air molecules in our whole atmosphere, going all the way up miles and miles, half of those molecules and atoms are found in the bottom few miles, really, and it goes up so many miles. So the air becomes a lot, there's more pressure as you go farther down. So a big thing with meteorology is a decrease in air pressure with height. That's a big concept in meteorology. As the elevation increases, the number of molecules decreases, the density is less, and there's a decrease in air pressure. So when we talk about the different elevations, again, if you're at a higher elevation, you have a lower air pressure. If you're near the surface, you would have a higher air pressure. At these different observation sites all around the world, it's hard to talk about pressure when you're all at different elevations. You might be somewhere in the middle, a town might be somewhere higher or lower than another one really close, and they would have different pressures, but it would be really hard to kind of understand whether it's becoming high pressure or low pressure. So the idea is that the pressure reading, regardless of the elevation, is converted to a value that would be observed if that station, that observation site, were at sea level. And so there is some conversion there. There are units of pressure that we talk about, which I will show you really quickly. And for example, this sea level pressure that we talk about these are what it is in different units: millibars, hectopascals, inches mercury. So any of these would be the pressure at the surface or at sea level. If you go and get a high pressure system moving in, then these numbers would be higher. And if you have low pressure, it would be lower for all of these. And interestingly, you can see that a millibar and a hectopascal exactly the same. So you would just move the decimal point if you wanted it to be a pascal, which was kind of the traditional unit for air pressure for a lot of people and scientists and so forth. So now is when I think it gets a little bit fun. We talk about high and low pressure. So this is such a big part of our job. You guys have seen it, right? The big H, the big L that we're always showing. So when we have high pressure, and if you can remember this, this is just a really kind of important meteorological thing to remember, and actually it really helps even for forecasters just every day to kind of keep in mind all of these things. When we read the forecast discussions coming in from different meteorologists, and when we talk amongst ourselves, all of these principles come into play. With a high pressure, that is when the air, by the way, there are circulations around these, when the air is flowing down and out. If you can remember that, then you'll have a pretty good idea of what it means when high pressure comes in. A lot of times that translates into sunny and hot weather because there's a downward movement in the atmosphere. So you can kind of imagine the high pressure kind of sitting over an area and the air is flowing down and out. And so this kind of sinking motion is what keeps clouds and rain from forming. So a lot of times that prevents clouds and rain. It makes it sunny, and that allows the area to heat up more. Also notice the circulation around the high is clockwise and what we would call an anticyclone. All of this really good information, again, if you are interested in weather and meteorology. Another one is, of course, the big L, the big low pressure area that if you were watching some of our weathercasts yesterday, for example, we had a huge L, we had a huge low pressure area to our north, and we were seeing the rain actually truly spiraling around the low. I know you've seen that. Obviously a hurricane or a tropical storm is like that, and sometimes even a low pressure area over just land. So you can see with this one, the air is flowing in and up. And so that is what provides some of that lift in the atmosphere. And so when you have that plus moisture, you would get lift in the form of, and that would become eventually the formation of clouds is what we would see with that, and eventually maybe rain and storms. So for low pressure, there's not as much pressure, the air is going in and up. This would be also another kind of word for low pressure, or kind of something related would be a cyclone. So when we talk about cyclone, at its very simplest sort of definition, it means an area of low pressure, and that would have a counterclockwise rotation, by the way, around the low. So yesterday when I was up early and Sunday night too, when we were showing that low pressure area that brought some showers into our area, there was a big L on our weather map, and then you could see the rain just spiraling around it. And again, if you note on our weather maps with L's and H's denoting the lows and highs, you can kind of see a lot of times either the cloud spin around these, or the rain, actually different areas of rain kind of spinning around, especially the low, of course, and sometimes around a big high pressure area. We sometimes call it the ring of fire, if you guys know about this, where there's a huge area, this happens sometimes in the summer, of high pressure. It is bringing the air down, it is bringing the air out. and it's making it hot and humid and kind of stagnant feeling. But around the high pressure, where the high pressure kind of loses its hold, sometimes you can see where the high pressure is not as strong, there will be a ring of strong thunderstorms. And this is usually a really big kind of system, not just a small thing, but you can kind of notice if you look at kind of the eastern or middle part of the entire US, you can kind of see this trend of showers and storms generally in a ring, and you would know that there was high pressure in the middle if there's no storm activity there, and then way around the edges is where the showers and storms are able to form, but not so much with the high because there's this downward motion and it's sinking. So I think we covered a pretty good bit in this weather lesson talking about high and low pressure. I don't want to go too much more. There are lots of related topics, but I hope that does help as you kind of look at our weathercasts and look at other sources of weather information, that you can kind of keep all of these principles in mind. High pressure, sunny, hot. Low pressure, generally clouds and rain, although it's not true all the time in those specific forms. And then also just kind of what air pressure is. Remember, when we're at the surface, we have more air pressure than if you were going to be farther up, like on a mountain. And then if you go way, way up in the atmosphere, very, very little air pressure to deal with once you get toward the top. And that's because, really because of gravity, bringing many of the air atoms and molecules kind of closer to the Earth, and then getting less and less as far as those air molecules go, the farther away from the surface you get. So I hope this one was pretty good for you guys. This one was just about air pressure, super basic meteorology thing that we talk about all the time, but that I kind of just wanted to go into a little bit of detail about because it's sometimes something that we just kind of mention, but it's kind of cool, I hope, to be able to see a little bit of the workings of why the high makes it sunny, why the low makes it a little bit more likely to have rain and so forth. So that'll do it for today. This is our Tuesday afternoon weather lesson. I'll be back with one more. I am baking tomorrow. I'm pretty excited about it. And it's a pretty fun, easy little recipe that I hope you guys enjoy. So I'll be back on Facebook Live on Wednesday, 1 p.m. Join me for that. We'll be talking about a recipe I want to make. And in the meantime, enjoy today. I mean, it's pretty hot, but it's not terrible humidity, I think, just yet. Not quite at summertime sort of levels, although we're almost getting there, especially by the end of this week. That'll do it for today, guys. Thank you so much for joining me. Hope you have a great rest of your day.